Welcome to Mr. Davis's math class. This is Algebra 1 and we are on lesson 6.5. Today we're going to continue talking about linear inequalities. We started this lesson previously and now we're going to finish it up. So we're going to do 3 different examples today and just kind of expand our knowledge on linear inequalities. So first one we're going to be graphing, but this time there's only one variable, right? So this time, only one. There's not 2, there's not an x and y like there was last time. So what we need to remember is what do linear equations look like when it's just x equal, and what do they look like when it's just y equals? So there's only one variable each. Now we should remember that if it's x equals, it should be a vertical line. And if it's y equals, it's a horizontal line. So those are our 2 different types of graphs. And once we know that, it's actually pretty easy to do these types of problems. So let me get down a graph here. Oops, wrong one. Let me put that back. There we go. Okay. So once you know that, it's pretty easy. So let's start with A, which I'll do in blue. Kind of similar process last time. There's a greater than symbol. So I know there's no equal or equal to part, so it's not a solid line. It's a dotted line. A dotted line at where x is -1. Well, x is -1 right here. That's x is equal to -1. I know it's going to be a vertical line, and I know that's going to be a dotted line. So draw my dotted line. Now I need to shade. Okay? Now, we were talking about shading as above or below, but when we have a vertical line, there's not really an above or below. There's a to the right and to the left. Well, here it says x is greater than -1. Okay? So it makes sense that going to your right is greater than, and going to your left is a less than. So we're going to shade to the right side. Now, if you don't like that, if you like the test point method, well, we could test, again, 0, 0 is not on the line, so I could choose that one. I could test 0, 0, which I'm going to plug in 0 for x. And since there's no y, that other 0 doesn't really matter. So I get 0 is bigger than -1. Is 0 bigger than -1? Then we'd say that is true. So we would shade the right side, the true side. And that's how we do linear equations in one variable when the variable is an x. Now to erase this and do it with the y variable. So I'll do that one in red. So I know that the y variable can be a horizontal line at 2, and it's going to be a solid line. So here's 2 for y. You know, there's the y is equal to 2. It's going to be a horizontal line, and it's going to be solid. Now I can still think about this as shading above or below, and since it's a greater than, I know I'm going to be shading above. Those types of problems with the one variable should be easier to do if you can recognize them. So if you can recognize them, it should be easier for you to do. Here's your got it question. Right. Try these 2. If you need help, refer to the previous problem. All right, so here we have an interior design problem. We're going to remodel the kitchen. We have this wall above the countertop is going to be redone as they show here. We can spend a total of $420 or less. We want to write a linear inequality and graph the solutions. All right. So, and then they want 3 possible prices for wallpaper and tiles. Well, let's graph it, or let's do this problem. Well, first off, they kind of gave us a total. They said the total was 420. So 420 is my total. I can't spend more than that. So the amount that I have has to be greater than or equal to the amount I spend. All right? So we can think of this side as being spend, this side as being what I have. So what I have has to be greater than what I spend. Then on what I spend, I'm going to have a tile part and a papered part, right? And I need to add those two together because I have two different parts. First off, the tile part, well, the amount of money that I can spend on tile, and we'll go ahead and call tile X and papered Y. But the amount I can spend on tiled area, well, if I have 12 square feet and each square foot costs X dollars, I need to multiply those two pieces. So I have 12X, right? 12 square feet, X dollars per square feet. On the papered side, it's going to be similar, but 24 square feet, and Y is my variable. All right, so there we go. So that's our equation. All right, so this is what they were asking for to begin with. And then they said give 3 possible situations, all right? 3 possible. Well, I'm just going to make an XY table. All right, an XY table. And I'm just going to pick units, and then we'll solve from there. So first off, let's say we spend $1 on tile. Then I need to find the y. So I go 420 is greater than or equal to 12 times 1 plus 24y. Well, this is equal to 12, so I need a minus 12 from both sides. I get 408 is less than or equal to 24y. All right. Then from there, I need to divide both sides by 24. And we get, well, this side's going to be y. Over here, we're going to have 408 divided by 24, which is 17. Well, that first possibility is if we find tile for $1 per square foot, we can buy wallpaper for $17 per square foot or less. All right. Well, I'm going to kind of use a quick way. Now, I could pick another X and find another Y, but the only thing that says is I have to spend less than, right? So if I find tile that I really like for $1, I could buy wallpaper for $17, or I could buy wallpaper for $16 and stay under my budget, or I could even buy wallpaper for like $10. And those are 3 possibilities right there. So I found 3 possibilities, all with the same tile. They just had different amount of wallpaper. All right, here's one for you. Similar to the previous problem, so try to set it up the same way. And then 3 possible combinations. All right, here's the last problem for the day for us to do together. And it's multiple choice. We're going to match the graph with which equation it belongs to. Well, best way to do these is start to eliminate, okay? Well, first thing I see, solid line. Solid line tells me that there's a line underneath it, meaning or equal to, which means I can get rid of D. There you go, D is gone. Okay? Next, I can look at, say, the shading. The shading is below, and we know shading below is going to be a less than or equal to sign. So since I know it's a less than or equal to sign, that's going to get rid of C, because if it was C, it'd be shaded above. Okay, so we've eliminated 2. Now we're to these last 2. And if I look, everything looks the same except for right there, right? And that's the slope. So now I need to compare slopes. Well, remember, for slope, I can compare it by rise over run, looking at where they cross the lines nicely. So how do I go rise over run from there? I go rise of 1, 2, over a run of 1. So 2 over 1. So my slope is 2, which looks like that means it's A, not B, A is my answer. All right, try that same strategy with these two. Okay. And then your homework.